I remember the first time a professor told us in class that we were going to learn how to count, and we all kind of laughed. And then he went on to say that, counting is very hard actually, and we all laughed some more. And then after a while, we realized we need to pay attention to what he's saying a little bit. And so I'm going to go over some advanced counting techniques that can be confusing at first, but hopefully we can clear them up. And the three I'm going to look at today are multiplication rule, permutations, and combinations. And I want to start with the multiplication rule, which says this. If we make n choices with k sub 1 options for the first choice, that means whatever the first thing we're choosing, we have k sub 1 options for, k sub 2 options for the second choice, k sub 3 options for the third choice, I just said etc. here, going all the way down to k sub n for the last choice, we have k sub n options. Then what that means is there are k1 times k2 times k3 up to times kn possible ways to make these n choices. What does that mean? Let me just give you an example. This will clear it up immediately. So here's a very common situation. We have a basketball team and they have a 26 game season, and we're not allowing draws here, okay? So you have to play the games, and there has to be a winner and a loser. The question is, how many ways can the season play out? And what we mean by that here is how many different possibilities are for wins, losses for the team. All right, so here's how we're going to calculate this. We have 26 games. I'm going to put them with fill in the blanks. All right, so we have 26 games. So imagine this is 26 spaces, and for each space we can either win or lose. So for example, there could be a season where you have win, 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 they go undefeated and they just win them all. Okay, that's one. All right, but we got to count all of them. So what if we did this? What if we said win, loss, win, win, or win, win, loss, so on, so on. That's a lot to keep track of. In fact, that's really going to be very difficult to do all those by hand. So we're going to use the multiplication rule because I know for the first game there's two options, right? Either win or lose. For the second game there's two options. And for each one of these games we have two options. So by the multiplication rule, the number of ways will be 2 times 2 times 2 times 2, 26 times. So we get 2 to the 26th power. Here we're going to have to turn to our good buddy the calculator, and when you do that, when you type that in, you should get this number, 67,108,864 ways that this simple 26 game season could play out for this particular team. And I think with these examples, you see it's just astounding how quickly these numbers grow. Alright, now that's multiplication rule. Hopefully that makes sense. Let me move on now to permutations and combinations. For permutations and combinations, we have similar definitions, and it is important to pay attention to the wording. Okay, so for a permutation, we're talking about the arrangement of k items selected from a total of n items, here where the order matters. And that's the key identifier of a permutation versus a combination. For a combination, we're looking at the arrangement of k items selected from n items where order does not matter. Okay, does not matter. Let me give you an example. You have 6 friends. Pick 3. Okay, so let's say you pick your friends. You have your friend Robert, and you have your friend Kyle, and then you have your friend Lana. Now, if I just pick them without any specific order, it doesn't really matter as long as I pick these 3 people. These are the 3 people going to the movie with me. It doesn't matter who shows up first. Then that's a combination. However, let's say that I wanted to arrange them by who's my favorite, or who told the funniest joke, or who won the contest, and I arrange them like this: 1 Robert, 2 Lana, 3 Kyle. Now all of a sudden I'm talking about a permutation. So if the order matters, you're talking about a permutation. If the order does not matter, you're talking about combination. Now for notation, typically a permutation, you could see it written like this, and that's saying that we have n items and we're selecting k from them. And the mathematical formula for this is going to be this n factorial over n minus k factorial. That's how you calculate it. For a combination, the notation is n ck like that, or sometimes, depending on what your textbook is, and this is more common in higher mathematical texts, we have this symbol here, which is called a binomial coefficient, and you read this as n choose k, or the number of combinations of selecting k items from n can be calculated like this: n factorial over n minus k factorial, so it looks like a permutation, right? Except we divide also by k factorial. And this counts the number of combinations selecting k out of n. And this n pk up here at the top counts the number of permutations selecting k out of n. Let me show you how to manipulate these expressions because they can be kind of unruly. And then let's look at some examples. All right, so we just want to learn how to manipulate permutations and combinations. So look at this. We want to calculate 6p4 over 6c4, okay? So I'm just going to plug in according to my definition. Remember, the number of permutations is going to be n factorial divided by n minus k factorial. So for 6p4, that's going to be n is 6, right? That's going to be 6 factorial over 6 minus 4 factorial. In the denominator, we have 6c4, okay, going by my combination formula. That's going to be n factorial divided by k factorial, which is 4 factorial, divided by 6 minus 4 factorial. Okay, now if you just try to plug this into a calculator just like that, you may get frustrated because these factorials are big numbers, generally speaking, even for small values. All right, so what I'm going to do here is I'm going to remember that dividing by the fraction, a fraction is the same as multiplying by its reciprocal. You got to keep that in mind. So this is going to be, I'm having this fraction up top, and 6 minus 4 is 2, right? So I have 6 factorial over 2 factorial times this fraction down here in the denominator. Dividing by a fraction is the same as multiplying by its reciprocal, so I'm going to flip it upside down. I have 4 factorial times 2 factorial over 6 factorial. Now notice that the 6 factorials cancel out, so do the 2 factorials, and I'm left with 4 factorial, which is 4 times 3 times 2 times 1, which gives me 24. This value is just simply 24. Okay, now let's look at some real examples, combinations and permutations. Let me write down 2 of them because I want to figure out, are they combinations or permutations? We have to be careful with the wording. All right, so now example 3, we say, with 29 guests at a party, how many ways can 4 guests be arranged to sit on a couch? Okay, now the first thing you have to decide is this really a combination or a permutation? And the way you do that is think, does the order matter? You have to answer that question. So you've been at a party, and let's suppose you're at a party where there's a girl that you like at this party, and you're trying to sit next to her on the couch, right? You better believe that order matters. When you think, okay, so with 29 guests at a party, how many ways can 4 be arranged to sit on a couch? This is definitely a situation where the order matters. That means we're dealing with a permutation. With permutation, remember, the order matters. So here, how many ways can 4 guests be arranged on a couch? We are looking at 29p4, which is by a formula, 29 factorial over 29 minus 4, which is 25 factorial. Now again, if you just plug that into a calculator, you're going to be frustrated because these are very large numbers. You can remember that 29 factorial is just keep multiplying down, but eventually when I get to 25, let me stop because that's 25 factorial divided by 25 factorial, right? Because this 29 factorial means 29 times 28 times 27, blah, 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 times 25 times 24 times 23. All this tailed in is actually 25 factorial, and it's going to cancel out very nicely for us. And so now I just need to multiply 29 times 28, 27, and 26, and I get 570,024. That's how many ways the 29 people you can arrange 4 on a couch. And wouldn't that be a fun party to be at, trying to figure out all the ways to do that? I think that'd be fun. All right, now for the second one, we say out of 22 classes, 5 are going to be selected to be surveyed. How many ways can the 5 be chosen? How many ways can you pick those 5 out of the 22? Now let me ask you, does it matter if you're the first or the second class to be chosen? Not really, because you're going to take the survey regardless. And so because of that, the order here does not matter. As long as you're chosen, you are in the group. Okay, it doesn't matter if you're the first or the third or the second or whatever. So that means that this is a combination. And that means we are calculating then 22C5. Okay, So according to my formula, that is n factorial over k factorial times n minus k, so 22 minus 5, 17 factorial. All right, now let's see how we can do this. So I can cancel out the 17 factorial by saying 22, 21 times 20 times 19 times 18 times 17 factorial over the 17 factorial, and those will cancel out. And I'm going to write out the 5 factorial is 5 times 4 times 3 times 2 times 1. All right, now the interesting thing is the denominator will always cancel out, which doesn't always seem like it should, but watch. Okay, so the 5 and the 4 multiplied to give me 20, so there's 20 right there. And cancel those out. The 3 and the 2 is a 6, right? 3 times 2 is 6, so I can cancel that out with 18, and 6 divides into 18, I get a 3 up here. And then the 1, well, I'll just have a 1 in the denominator, that's not a big deal. So what I'm left with is 22 times 21 times 19 times 3, and that is the number of ways I can choose these 5 classes to be surveyed, and I should get 26,334. All right, I hope this makes sense. I have one last question I want to show you because I want to relate this to probability, because that's really most of the time why we're looking at these type of questions. All right, so here's my last example, example 5, where we have a local pizza parlor is going to run a special to encourage their customers to try new combinations of toppings. So what they do is they're going to have all possible 2-topping pizzas on the individual cards, and they're going to give a free pizza away every hour to a lucky winner. What we want to do is find the probability that the first winner randomly selects the card for the pizza that has green olives and green peppers. Okay, and also here's the list of possible toppings, all right? And if you count these out, there are 13 different toppings available. Okay, but this is not a 1-topping pizza, it's a 2-topping pizza. So the real question is not just the probability, but how many pizzas are possible? Okay, and so I'm trying to think, is this a multiplication rule? Well, no, not really here. Maybe a better way to think about it is a permutation or a combination. And so does the order matter? So if the guy gets the pizza with green olives and green peppers, is that the same as the pizza with green peppers and green olives? Yes. So these are combinations here. And we know there's 13 toppings, and so we need to calculate the number of ways that out of 13 you can pick 2. I like to write it like this. That's more mathematical. The 13 choose 2. And so that's going to be, by definition, 13 factorial over 2 factorial times 13 minus 2, which is 11 factorial. All right, and this will clean up pretty nicely because look, you have 13 times 12 times 11 factorial over 2 factorial over 11 factorial. And notice that 2 factorial is actually just number 2, right? It's 2 times 1. Okay, and so then the 11 factorials cancel out, a 2 and a 12 cancel out, give me 6. And so I just have 13 times 6, which is 78. That is the number of ways to get a 2-topping pizza. Now, the question is asking what's the probability that what's the probability of the first pizza being green olives, green peppers? Okay, so out of all the combinations of 2-topping pizzas, there's only one that'll satisfy that. So it's going to be 1 divided by number of 2-topping pizzas. All right, and well, you know what? We just calculated that. That's going to be 1 out of 78. Okay, so there's your example. So there's your solution. And they asked to express your answer as a fraction in lowest terms or a decimal rounded to the nearest millionth. Let's keep it like that. 1 out of 78 is beautiful. Okay, so that's your probability of getting the green olive, green pepper pizza. I hope this makes sense. Guys, if you have any questions on this, please let me know. My advice is to pay attention to the wording and ask yourself, does the order matter? Because that's where it really comes into play. If you have any questions, let me know. I'll be glad to help. And thanks for watching.